Hello. I want to go over this leak code question, transpose matrix. Um, so essentially we have a matrix with, in this example, we have three rows and three columns. And what we have to do is convert the first row into the first column, the second row into the second column, the third row into the third column. So just right here in the image. Um, so here I'm gonna just copy this onto here. We have a vector of a vector. Um, so essentially, we're going to have one big vector with mini vectors within. Okay, so before I actually do the solution, I want to show you guys um, my thought process behind this question and how I did it. So we're going to have, let's just copy this again. We're going to have a vector of a vector called matrix. And then here, I'm going to show you uh, so here the purple parentheses are the big vector, and then the blue ones are the is the mini vector within the big vector. So we have one, two, three, and then I'm gonna do this so it's easier to see. Four, five, four, four, five, six, seven, eight, nine. So essentially, these are technically in like one single line, but I did it like this so it's easier to understand and visualize. So this would be row, if we're talking about computer science, this is row zero or row one. This would be row one or row two. And then this would be row three or row two in this case. So essentially, what we want to do is traverse this, these, and then just swap them out. Um, put this going vertically up and down instead of left and right. So what we're going to do is we're going to say in rows, not toes, rows is equal to the matrix dot size. So what this is saying is we're gonna grab the size, however many mini vectors are within this big vector. So in this case, it would be outputted three because we have one, two, three vectors, three mini vectors within. So that would be our three rows. If we added another vector, of course, our row count would be increased, so we would have four rows. Um, and then in columns, this one is a bit weird. We're gonna make it be either matrix dot empty. So we're gonna check if the matrix is empty or not. And if it is, we're gonna return zero. And if it isn't, we're gonna return uh matrix at array zero dot size. Um, so what this is saying is our columns are going to be whatever the zeroth um matrix is the size of the zeroth matrix. So because essentially we're gonna be bringing it down. So this would be our the length of our columns. So if we had one more element in here, the length of our columns um would be four. Um, so there we go. And then now um to show you guys the printed out matrix. So this is still technically in the single line. So I'm gonna show you guys um how it looks like printed out. Printing rows equal to zero, row is less than rows, plus row. Is it correct? Yeah. And then for in column is equal to zero. Column is less than columns, plus column. And then stdc out uh the matrix at the current matrix at the current row and the current column. And then just a space between them. And then we're going to do std out std end out. So this is so this here is going to go through each row. So in this case, we'd start off with this row and then just grab each number and print it. Once we're done, skip it, go to the next row, print them out, skip it, go to the next row, print them out. And then we can say std cout matrix. Uh, yeah, just matrix. No, oh, too many else. And if we run this is not it. Oh, oh, this is not it. Terminal. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just how this is. Right. Okay, so for now, transpose matrix is essentially the same thing as this, but I'm gonna say transpose matrix. But instead of printing the rows and the columns, we're gonna do columns. We're just gonna swap them columns and then the row. So if we run this, as you can see, 1, 2, 3 is now in the first column. 4, 5, 6 is now the second column. 7, 8, 9 is now the third column. Um, so we just transposed the matrix. So let me delete this. And now we're going to follow essentially the same ideas that we just did here. We're going to declare, we can just copy this because why not? Um, Let me see. There we go. Now rows and columns is whatever is within this matrix. And then I'm going to declare std, a vector of vectors. So a vector of vectors, let me just copy this, called result matrix, which is then going to have columns as the new rows, and then std vector int rows, and then however many elements within the rows as the columns. Uh, so here we're going to follow the same steps for int row is equal to 0, row is less than rows, plus row for int column is equal to 0, column is less than columns plus column, and then std. Oh no, we don't have to print anything. We're just gonna say result matrix at array. Like I said, swap them out at array column and array row is equal to matrix. The original matrix at array row um column. So we're just swapping them out, and then we're just going to return result. Not result, result matrix. Okay, and then within here, I'm just going to declare uh another matrix. Let's just copy this to make our lives easier. Result matrix. Um, and then here we're gonna and then we need a solution. Um, so here we're gonna say solution. Oh no, sorry. Result matrix, because we're returning a vector transpose. We're just gonna call result matrix is equal to solution dot transpose, and then pass in our original matrix. Uh-oh. And then we are just gonna copy this and then just rename them into result rows, result result columns, result matrix dot size, because we by this point we're already gonna have the size of the result matrix because of this right here. Result result columns. And why is this red? Oh, I'm tripping, sorry. Result matrix. And then we're just gonna copy this because it's the same thing. And instead of rows, we're just gonna say result rows, result columns, and then stdc out result matrix now at array row and column. And we just say row and column here again because essentially this is just doing all the swapping, and then we can just print it how it is. Result matrix. And if we run this, here we go. So the original matrix is, as you can see, 1, 2, 3. And the result matrix is 3, 2, 1, 4, 5, 6, 7, 8, 9. Just swapping them. So row 1 right here, 1, 2, 3. So this is how you do it. And then if I copy this and input this into here and run this, it is accepted. Okay, and then I'm gonna show you guys how the steps are on my iPad real.
Okay, so if we go over the code from the leak code, we're gonna have a vector of vectors of int of type int, and then we're gonna call this matrix. Right? So within this matrix, this is going to be, if we follow the example I had, 1, 2, 3. 4, 5, 6. 7, 7, 8, 9. So here, the blue parentheses are is the bigger vector, with the red parentheses being the vectors within the vectors. So in my example, we had int rows equal to matrix dot size. Now, essentially what this is saying is we're going to take the however many mini vectors are within this bigger blue vector. So in this case, we would have 0, 1, 2. We would have three vectors. So this would be equal to 3. Essentially, that's our rows. Now, if I were to show you guys how this looks over here. Hello. I'll show you guys over here then. Paste. If we move this down to here and this down to here, as you can see, we have 1, 2, 3 rows. So that would be our row. And then int columns was kind of weird, is equal to either matrix dot empty. So if it is empty, I'm going to use, it's going to be either 0 or matrix at array 0 dot at array 0 dot size. So essentially what this is saying is we're going to say if matrix is empty, return 0, else return matrix at first element size. So return the size of the first mini vector within the big vector. So in this case, our matrix is not empty, so we won't return 0, but in fact we would return matrix at array 0 dot size. So we come to here. So like I said, blue is our big vector, and then red is our mini vectors. So this would be at array 0, 1, 2. So we would come to 0 and return 3, because that's how many elements are within the first mini vector, so 3. So we have a 3 by 3 matrix. So, and then if we follow the next step, we have our M result matrix is equal to a vector of vectors of int. And then here we're going to say, we're going to just swap them out, columns, and columns is going to be the rows, and then a st, or not, don't do that, vector of type int of rows. So essentially this is saying we're going to have a column amount of rows, and then a row amount of columns. So, so let's say, for example, if columns was 4 here, we would have 0, 1, 2, 3, 4. Oh, sorry, that's 5. 0, I should start it from 1, 2, 3, 4 rows. And then each row is going to have a vector of amount of integers of size rows. So if we use this case as well, each of these rows is going to have a 1, 2, 3 elements within. Like that. So yeah, that's essentially what this means. Let me just delete this. Right, okay. So then we go into our for loops. For row is equal to 0, row, well, row is less than rows, row plus row, and then for column is equal to 0, column is less than columns, plus column. And then we're going to do our M result matrix at array column and row is equal to the original matrix at array row column. So if I drop this out, let me move on over here. We're going to copy this real quick. Let's paste this here. Sorry, I will delete those lines in just a sec. copy this again. And let me delete these guys. So here we have the original matrix and then result matrix RM. So here in our first iteration, rows is going to be 3, and then columns is also going to be 3 because that's what they are here. Let me change this back to 3. Right? So first off, we're going to start off at the 0th row. And we're going to complete all of the elements within that 0th row. So essentially we would have at result matrix at array 0, 0, matrix at array 0, 0. We come to here. We come to, if we do this first, matrix at array row 0, 0. Like I said before, these are our rows. So we would come to this row first at the 0th column, which would be 1. And then we would input that into where? Into result matrix row and column. But remember, we're just swapping them, right? So we come to here and just input 1 right there. And then in our second iteration, rows would still be 0. I can delete this. Column is now 1. So we'd return column 1, 0, 0, 1. So essentially columns in result matrix is our rows for the original matrix. So now, let me change the color of these, sorry. 0, 1, sorry, backwards. 1, 0, 0, 1. So now we would come to here, matrix at row 0, column 1. So we're still in row 0, column 1, which is 2. We would input that into column 1, row 0, which is essentially row 1, column 0 of this one. So we would input 2 here. And then for our third loop, we delete this one. And then update this to 2. And then column at 2, 0, 0, 2. 2, 0, 0, 2. So come to matrix at array row 0, column 2, which is here. We're still in this one still. Column 2, which is this one, and input that where? Essentially, this is row. So because we're flipping it, row 2, column 0. So in this one, row 2, column 0, input 3 here. And then once we finish this, as you can see, column is equal to 2, while column is less than 3. If we try to add it, 3 is not less than 3, 3 is 3. We would now exit this inner loop and update the outer loop to 1. So now this is 1, columns resets back to 0. And we do the loops all over again, but in this case, row would be 1, 0. This is row 1, element 0. So now we reset to column, or essentially come here to matrix row 1, 0, which is now we're in this one right here, row 1, 0, which is 4. Input that into column, or sorry, row 0, column 1 of result matrix, which is row 0, column 1 of result matrix 4. It's a bit confusing because the wording is different, but essentially this is row, column. And then we just do that for all the loops. So next, we would go to this. Uh-oh, shoot. We would come to this one, sorry. This one, 5, row 1, column 1, which is 5, and then input that into this one, which would now have 5, and then 6 would go to here. And now 7 that would be our the end of our big outer loop. Then we update the big outer loop to 2. And now 7 would go there. 8 would come here. 9 would come here. And as you can see, if I draw this out, 1, 4, 7, 2, 5, 8, 3, 6, 9. As you can see, the rows have been flipped. They used to be going this way. Now they're going up and down. Up and down, as you can see. So, yep, that's the end of this video. Hope y'all enjoyed and hope y'all understood.